prior knowledge in examining patterns. So today we're going to look at two different patterns. I would like you right now to make a prediction. So they are asking you to predict, what do you think it means to have a negative exponent? That would mean something like, what do you think this is equal to? What do you think if I have this? That's a negative exponent. So I want you to just write a prediction. What do you think would happen? So I need right now in your notes for you to make that prediction. The other thing I want you to predict is, what if you have something to the 0 power? So put these two down and please make a prediction right now.
Property, and that's that anything to the 0 power equals 1. And if you want to understand that a little bit better, just take a simple example. Let's say you had x cubed divided by x cubed. Well, when you use the quotient rule, right, from up here, when you divide, what you do is subtract. So that's going to be 3 minus 3, which is 0. And this property tells us that anything to the 0 power is 1. But it makes sense from the standpoint of, you can see this is x cubed divided by x cubed. Anything divided by itself is 1. Okay, so you can see how that works there. But if you see here, x to the 0, this would be 1. And then this one here sometimes tricks students a little bit, but it's this whole quantity raised to the 0 power. It looks like there's more that needs to be done, but really, since this whole thing is being raised to the 0 power, the answer is just 1.
So the key thing, some of your predictions, you thought it was the same thing, you thought it was 0. Anything to the 0 power is always 1. It's a very easy quiz question. It's a very easy test question to have something as simple as this to get it equal to 1, and as something as big as this and get it equal to 1. Okay? So now he's going to talk about the negative exponents.
1. Okay, and then the last one here, we're talking about negative exponents. And you can see here, a to the negative m power is equal to 1 over a to the positive m power. Now, a lot of students make the mistake of thinking that when it's a negative exponent that makes the number negative or the base negative, but it doesn't. The negative exponent is really just a symbol that tells us to take the reciprocal or to move this quantity to the other side of the fraction bar, and then you make it a positive exponent. So let's look at some examples. X to the negative 2 is the same as 1 over x to the positive 2. Okay? Let's look at this one a little more challenging. So 5 over 20, that reduces to 1/4. And you can see x to the negative 2, what I'm going to do is I'm just going to take this quantity, I'm going to move it to the other side of the fraction bar. Okay, so when you have a negative exponent, just move it to the other side. If it's in the denominator, move it to the numerator. If it's in the numerator, move it to the denominator. This rule with the negative exponent just tells us to take the reciprocal. That's going to move it from one side of the fraction bar to the other. The y is a positive exponent. We're just going to leave that where it is. And then the z to the negative 5th, that's a negative exponent. We're going to move that to the other side of the fraction bar. Since it's in the denominator, we're going to move it up to the numerator and make it a positive 5.
So when you are looking at these, that's what we're going to be talking about today as we are taking a look at our exponent rule. So when we look at, some of you predicted negative exponent, you thought it was going to make it negative, give you a negative number, and now we know it's a reciprocal. So as you are looking at this page, they started this first one and it says, look at it, take the table and fill in the blanks. There is a pattern that will help you as you go down each table. So 16, 2 to the 4th equals 16, 2 to the 3rd equals 8, 2 to the 2nd is 4, 2 to the 1st, 2. What's happening to go from 16 to 8? What are you doing? Dividing by 2. 8 to 4, we are dividing by 2. So if we keep that pattern going, right, taking 2 and dividing it by 2 is 1. Negative exponent. We just said in that video, negative exponent means to take the reciprocal. But what we want to do is think of what 2 to the 1st was. It was 2. 2 to the negative 1 is going to be 1 over 2. Taking 1 and dividing it by 2. So as I continue going down this table, I notice that 2 to the 2nd is 4. So 2 to the negative 2 is going to be, make sure you're filling yours in, 1/4. 2 to the 3rd was 8. We are taking the reciprocal, and if I take the reciprocal, I should get 1/8. And if I take 1/4 and divide it by a half, and so 1/8 divided by a half, or divided by 2, 1/8 divided by 2 is going to give me 1/16. Make sure you have your table filled in. I now want you to go to the 3's. 3 to the first is 3. Go up. 3 to the second, 9. What are we doing to go from 3 to 9? Times it by 3. Fill in your table going up. Start here at 10. 10 to the second, you know, is 100. Fill your table going up. Do that in this case. Each time we are doing what, Juliana, as we go down? Divide by 3. So 3 divided by 3, if we are looking at that, Gavin Murray is going to give us 3 divided by 3. 3 divided by 3 equals 3 divided by 3 equals, Gavin? Can you answer 3 divided by 3 equals what? You're just answering my question. What is 3 divided by 3? 3 divided by 3 equals what? 1. Okay. So if I take 1 now, and I'm using this pattern that I'm dividing by 3, 1 divided by 3 should be 1/3. The other thing is that is the reciprocal of 3 to the first. So Jacqueline, as I continue, and I take 1/3 and I divide it by 3, should be the reciprocal of 3 to the second, which is 1/9. The next one, Grace, if I am looking at 3 to the third is 27. This will be the reciprocal, 3 to the third, 1 over, which gives us 1 over 27. So since I know 3 to the fourth is 81, Olivia, 3 to the negative fourth is going to be the reciprocal, which is 1. Please fill in this last table, looking at your pattern, or thinking of reciprocals, right? That these will always be the reciprocal, right? So fill in your last table, do that right now. So as I 1
over 10.
Keep going.
1 over 100. 1 over 1,000. And then 1 over 10,000.
Thank you. So the question says in the first table, what is the pattern as you go down the table? So as we were looking at that table, Amy, in that first one, what were we doing each time as you went down the table? Dividing by? Go to the very first table, not the last one. So the first table, we were dividing by 2. When we look at that next one, you're going to be telling me, what are we doing in table 2? You're going to put that one. We are dividing by 3, right? Then they ask you what you're doing in the last one. So please make sure you fill those 3 things in on your notes. So the first one was we are dividing by 2 each time. We're going to fill in the rest of that. The second table, our pattern would be, Jennifer, we are dividing by second table by 3. The third table, as we are looking at it, is telling us to divide by what as we are looking at that, Ashley? Divide by 10, okay? And this is as you go down that table, right? So we're dividing by 3, divide by 10, divide by 2. It says, when we look at that, the key thing that you want to keep in mind is that when you have 2 to the 0 power, it is always equal to what? Anything to the 0 equals 1. And then please put down negative, you should be writing with me at this point, negative exponents means reciprocal. So we're going to put 2 to the third, which equals 8, and 2 to the negative 3, which is equal to 1/8. When we were dividing by 3, as we go down our table, the next thing that we want to write with dividing by 3 is that negative exponents mean to take the reciprocal of the positive power. So again, if I'm looking at 3 to the second equaling 9, I am then going to put 3 to the negative 2, which would be, as we start, 1 over 3 to the second, or simply 1/9. Okay. Same in that last one. 10 to the 0 equals 1. Anything to the 0 is 1. So we want to keep looking at those patterns as we continue. So it says, we look at the patterns that we've talked about. What can we say about any number to the 0 power? If I have any number, doesn't matter what it is, or I have variables, any number, please write down, to the 0 power will equal 1. The only thing you have to be careful for is if you have something like this, negative, and then you have 4 to the 0. If I'm looking at this one, and sometimes it's only written like this, negative 4 to the 0, it means negative 1 times 4 to the 0. That means negative 1 times 1. This one would come out to be a negative 1. What if I have 7x to the 3rd y, all of that to the 0 power? Equals 1. So if it's to the 0 power, it's 1. But if you have a number out in front of this, like you have this negative, so looking at the ones down below, we are going to do those right now. So Julia, start us off. 5 to the 0 should be 1. Fisher, G to the 0 should be 1. Sadie, negative 3x to the 0 should be 1. If I am looking, Lisa, at 3 plus 4 times 9 divided by 12 to the 0 should be 1. So anything to the 0. And this is the one that I'm talking about that you need to be careful about. This right here is a negative 1 times 4 to the 0. So the 4 to the 0, if we are looking at that, 4 to the 0, that's negative 1 times 1. So my answer to this one is negative 1 and not positive 1. Make sure you have that written down with my work that I have there. Okay? As you go to the top of the next page, it says that we're looking at a pattern. What can we say with any number with negative exponents? Key thing with negative exponent tells us to take the, what word am I looking for, Michaela? You remember? In our notes, or when he had it in the video, starts with an R, negative exponent. I had it on those tables, negative exponents. Tells us to take the what? The reciprocal. Negative exponent means take the reciprocal of our number. So we're going to be taking the reciprocal. So when I have a problem, and here is one, and I have 4 and x to the negative 1. First question I want you to think about is, what power is 4 raised to? If there's no exponent there. That really means 4 to the 1 and x to the negative 1. So my negative exponent is only here. So in that video when he was showing us, we're going to keep the 4 in the numerator. Why? It's not a negative exponent. We're going to move the x down here, and it's now x to the 1. And a lot of times people will leave this answer as 4 over x. So what if I have a problem and we are taking a look at it, and I give you something like 2x to the negative 3, y to the negative 4. Does the 2 move? Actually make this negative 2 out in front. Negative 2, x to the negative 3, y to the negative 4. Write that problem down. As you take a look at it, negative 2, what is my exponent as I take a look at that exponent? Isa, what is the exponent if there's nothing there? Does it make sense that it's a 1? So should I move negative 2? Is it a negative exponent? No, negative 2 stays. Someone said, but it's negative. Only the negative exponents. So now I'm taking a look at it. And as I look at that one, Audrey, looking at x to the negative 3, what's going to happen to that? Going to move it to the denominator. It's now going to be positive. Does that make sense? So negative, we take the reciprocal. It was in the numerator, as he said in the video. It now moves to the denominator. Okay? Macrina, as I'm looking at y to the negative 4, it was in my denominator. We are now going to move it to the numerator, and it's going to be y to the 4th. So this would be my simplified answer, okay? When we look at 2 to the negative 2, one of the first things I would hint of that I would give you is any of these that have negative exponents, put it over 1. Why aren't we going to put this one over 1? Because it's already a fraction. So I want to think of it as a fraction. So as I am looking at that, Olivia, 2 to the negative 2, I'm going to rewrite it as 1 over, to what power? It was negative in the numerator. We move it down and it becomes positive. Okay? So it was negative in the numerator. That means take the reciprocal. 2 to the second is 4. My answer would be 1/4. Okay? James W., if we're looking at this next one. 3 to the negative 4. How am I going to rewrite it? 1 over 3 to what power, James? 3 to the 4th. In your homework tonight, I need this step. If you don't put this step down, I'm not going to be giving you credit on your quizzes and on your homework. So I need to see that you know that it means to rewrite it, not just put it in your calculator, possibly. And this would give us 3 to the 4th is 81. Thinking about 3 to the 4th, that means you are multiplying not 12, but 3 times itself 4 times. The next one, as I take a look at it, Nick, I have m to the negative 6 over 1. 1 over m to the 6th, and we're done with the problem because we don't have to rewrite it any more than that. This next one, we want to find the reciprocal of 1/7. Lisa, the reciprocal of 1/7 should be 7. So when we find the reciprocal, right, the reciprocal of 1/7 is simply 7 over 1. 7 over 1, since we found the reciprocal, we're now going to put a positive exponent. Negative becomes positive once you take the reciprocal. So we now have 7 squared over 1 squared, which is the same as just 7 squared, or 49. As you are looking at your this next part, we want to simplify before we go on to our homework. So simplify the exponent. That means you cannot have any negative exponents, and you want to get it down to just one number. So Evan, if we are starting off negative 4 to the negative 2, we're going to put it over 1. We're going to rewrite it as what?
Negative 4. No, 1 over negative 4 by the second power.
Yep. And negative 4 times negative 4, if I'm multiplying that, gives me 16. Negative 4 times negative 4 is 16. So I'm looking at the next one. Amy, I have 6 to the negative 2. How am I going to rewrite the 6 to the negative 2, even if I think of it being over 1? To the second. Okay. Then I have 5 to the 0. 5 to the 0, if I am looking at that, Juliana, is going to be what? 1. So I have 1 times 1 over 6 squared. I have 136 times 1. That is 136. Do I need you to show all of this work? No. I'm probably okay if you go from this step right here and show, and then go to this step. So this next one, Jacqueline, we're looking at 3 to the 0, which is equal to 1, times, Julia, 3 to the second, 9. And my answer, 1 times 9, would give us just 9 for an answer. When you simplify with exponents and you have expressions, you can only have positive numbers as exponents. No zeros, no negative exponents. So on our quiz and test later, you will need to make sure yours are always having a positive exponent. So when we look at this, if we're simplifying this first one, say y to the negative 3, we might want to think of it over 1. How am I going to rewrite that? What would it look like? Negative exponent, we need to take the what? Take it positive. And to make it positive, we have to do the reciprocal. So if it's in the numerator, up here, right on top, now we got to put it as what? Tell me what to write. And it is now going to be 1 over y to the third, and we are done with our problem as we look at that. Fisher, we're looking at the next one. We have k to the 0. K to the 0, we are looking at equaling, is equal to 1. As I'm looking at that next part, as I look at k to the negative 2, Gavin. Right. And 1 over k to the second, if I take that times 1, that is 1 over k to the second. Okay? So when you're looking at those answers, that's kind of what you're going to be looking at as you do the problem.